Hello, today we will be covering lesson 3.5, proving lines are parallel. You guys will be able to recognize angle pairs that occur with parallel lines, and you'll be able to prove that two lines are parallel. We are going to skip this because we have not yet covered this in chapter 2. Once we get to chapter 2, we'll be able to do these things. So this first paragraph about identifying parallel lines is kind of a real-world application. The two sides of the track of a roller coaster are parallel, and all the supports along the track are also parallel. Each of the angles formed between the track and the supports are corresponding angles. We have learned that corresponding angles are congruent when lines are parallel. The converse of this relationship is also true. So, if you recall, we have a corresponding angles postulate. Now we have our converse of our corresponding angles postulate, and yes, you do have to write all of this out. You can't shorten it. So if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So if we are given that 1 and 3 are congruent, we know A and B are parallel. Same thing with 2 and 4, 5 and 7, and 6 and 8. We only need to know that one of the pairs of corresponding angles is congruent to state that our lines are parallel. So I'm going to give us a quick reference here. When we have our converses, we are given that angles are congruent. So if angles are congruent, then we have parallel. Originally, for our original theorems and postulates, if we had parallel, then we could find congruence. So it's very similar to what we started with, but just backwards. We also have a parallel postulate. If we're given a line and a point not on the line, there is only one line through that point that is parallel to our given line. You can't draw any other line parallel to it, there's just one. And we have our other 4 proving lines parallel ideas. We have alternate exterior angles converse. This says if two lines in a plane are cut by a transversal, so that a pair of alternate exterior angles is congruent, then we know that the two lines are parallel. We have consecutive interior angles converse. If two lines in a plane are cut by a transversal, so that a pair of consecutive interior angles, 4 and 5 in this case, are supplementary, they add to 180, then we know that our lines are parallel. We have alternate interior angles converse. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, 6 and 8, then the lines are parallel. And perpendicular transversal converse, we don't use this one as much, but it exists. If in a plane, if two lines are perpendicular to the same line, then they are parallel. So perpendicular, then parallel. Notice on all of these, no matter what is that our if statement, our lines are parallel. Okay, so let's try some. Given that angle 1 and angle 3 are congruent, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So angle 1 and angle 3, if we recall, are corresponding angles. So we can use the converse of the corresponding angles postulate Yes, you do have to write it all out. To say that our two lines, A and B, are parallel. Your homework, you'll have to do both of these steps as well. What if instead we are given angle 1 and angle 4? Angle 1 is 103 degrees, angle 4 is 100 degrees. Can we state anything about these two? If they were the same degrees, we would say that they are alternate interiors, which means our lines would be parallel. A and C would be. But because they are not the same degrees, we cannot state that any lines are parallel. Because we don't have congruence. We can say angle 1 is not congruent to angle 4. Another set, which lines, if any, must be parallel because of the given information? State which postulate or theorem we use. Now we have 1 and 5. 1 and 5 are, once again, corresponding. So by the converse of corresponding angles postulate, we have parallel lines. M is not even the question. We have parallel lines L and N. Okay, now we're looking at 5 and 6. 5 and 6 are congruent. They are vertical angles. But vertical angles don't tell us anything about parallelness. So we can say angle 5 and angle 6 are vertical. But we can't prove parallel lines. Same thing if they had given us, say, angles 3 and 4. They are supplements. They do add to 180, but we can't prove anything about parallel lines. Only the ones that we have today can make things say parallel. So 2 and 3. Outline my angles, decide what's my transversal and my two parallel lines in question. So the questioning lines are L and M. 2 and 3 are alternate interiors, so by the alternate interior angles converse, we know that angle L is parallel to angle M. All right, and lastly, we have angle 4 and angle 5. We have a line and an angle, angle. So we have M and L are in question, with P being our transversal. These guys are consecutive interiors, so by the consecutive interior angles converse, we know that M is parallel to N. Okay? We have 2 more slides. We are going to do a little bit of algebra to find the value of the angle ZYN so that these guys are parallel, which means our alternate exterior angles must be congruent. So we have 11x minus 25 must be congruent, or we can set it equal to 7x plus 35. That will make these two, PQ and MN, parallel. Go ahead and solve. We get 4x equals 60. So x will equal 15. Now we're not done. We have to plug it back in. So to find the measure of angle ZYN, we have 7 times 15 plus 35. 7 times 15 is 105. So the measure of our angle ZYN will equal 140 degrees. that means the other angle PXW has to have a measure of 140 degrees as well. And we should also probably write that this is by the alternate exterior angles converse. All right, and lastly, we have to find x so that GH and RS are parallel. So we have this angle and we have this angle. That means they are alternate interiors. So we'll use the alternate interior angles converse. We know alternate interiors will be congruent so that those two lines are parallel, so we set them equal and solve. So x will equal 9. And we don't have to plug it back in, so we have our converse theorem stated and our x equals stated. And that's all. Make sure you guys are thorough in your work, and you should be good. Have a great afternoon.